All right, so today's lesson is day 2 of what we did yesterday. We are working with graphing lines and relating slope to parallel and perpendicular lines. So we are going to use the formulas that we did yesterday to figure out if lines are parallel and perpendicular. So one of the things that you need to remember is that if we have slopes of parallel lines, they are the same. If lines are parallel, then they have the same slope. Slopes of perpendicular lines are opposite and reciprocal. Opposite and reciprocal will become more clear in just a minute. So those are the two things that we need to know. The key concepts are that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. So now here we are looking at this first example. Are the lines parallel? And explain. Well, the first thing we need to do always is to put it in slope-intercept form so we can figure it out. Put it in slope-intercept form. Well, I'm looking at both of these, and I noticed that this one, the first one, is not in slope-intercept form at all. Okay, so let's take that equation and convert it to slope-intercept form. 2x plus 5y equals -1. So in order to get y on the left-hand side by itself, we need to take away 2x. So we have 5y equals -2x minus 1. Okay, well, that's still not quite right because we need y alone. So we have to divide everything by 5. So y is alone, and we have a -2/5 x minus 1/5. Okay, well that's one of the lines. Okay, now we have to do the second one here. That's almost in slope-intercept form, except it's 10y, so we have to reduce that equation. We have to scale it down. So 10y equals -4x minus 20. All right, well, I'm going to, in order to get y by itself, we have to divide everything by 10. So divide by 10, divide by 10, divide by 10. Alrighty. Y equals -4/10 x minus 2. Alright. Okay. I still need to reduce this fraction. This fraction reduced will be divide both of them by 2. We've got 2/5. -2/5 x minus 2. So now if you look at the slopes, -2/5, -2/5, they are both the same. So both lines are parallel. Looking at the slope, we can say, yes, slopes are the same. Slopes are parallel. Next one. We have to figure out if these lines are parallel using slope. Okay, well, this is easier because we can just count the slope on these two lines. So if I count left to right, I'm going to count from this point to this point, and then put it as a fraction. Remember, it's rise over run. So this is -1, 2, 3. So -3. And then I've got 1, 2, 3, 4, 5, 6. Okay, that was a +6. Let's look at this one. Oh, okay. Left to right, I'm going to count from here to here. 1, 2, -2. 1, 2, 3, 4. 4. Well, they don't look like they're the same, do they? But if we reduce now, we have to reduce. We've got -1/2 equals -1/2. That means that, yes, they're parallel because the slopes are the same. Now, if you look at the one on the right-hand side, I'm going to go from left to right again, counting this slope. This is 1, 2, 3, 4, 4 over 1, 2, 3, 4, 5, 6 over 6. And then this one left to right. This is 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so let's reduce them. This can reduce to 2/3, and this can reduce to 1/2. They are not equal, so they are not parallel. Okay, so now we are being asked to write an equation for the line parallel to y equals -1x plus 4 that contains point -2, 5. Okay, so the first step it says here is to write the equation in slope-intercept form. Well, that's already been done for us, so we don't have to do that. But we do need to figure out what the slope is that we need. So the slope that we need is going to be that -1. So the slope is going to be a -1. Now we're going to use the point slope form with that slope in order to figure out the equation for a parallel line. So then the point slope form, remember, is y minus y1 equals m times x minus x1. Okay, so I'm going to take x1, y1 and plug everything in. So y minus y1 equals m. Okay, that's this slope over here, -1 times x minus x1 is a -2. Okay, so let's distribute. We've got y minus 5 equals -x. -1 times a -2 is +2, but we retain that minus sign, so it's going to be -2. Alrighty then. So now we're going to add 5. Add 5. Y equals -x plus 3 is going to be an equation of a line that goes through this point and that is parallel to this line. Now we have to figure out if these two lines are perpendicular. Now remember at the beginning I said that perpendicular lines have an opposite reciprocal slope. So opposite reciprocal, that is right here. Opposite reciprocal. Both lines, oh, one line is not in y-intercept form, is it? This one right here. So let's put that in y-intercept form. So y-intercept form means I have to get rid of this x, so that means I have to take 9/2 x away from both sides. So I end up with y equals -9/2 x minus 7. So that's in y-intercept form. I'm going to write this one down here just to make them closer. Are these opposite reciprocal? Well, what I'm noticing is that they're reciprocal numbers. These two numbers are reciprocal. We flip them, but they're not opposite because this is a negative and this is a negative. So these lines are not perpendicular. If this sign right here had been a positive, then it would be perpendicular lines. Okay, now we want to figure out if these lines are perpendicular and using slope. So I'm going to count this line first and write down the slope. So I'm going to go up 1, 2, 3, 4, 5, 6, and to the right, so that's 6. 1, 2, 3, 4, 5, 6. All right. Now I'm going to count the other one, left to right. Here's that, and there's this point. Okay, so I'm going to count down. 1, 2, 3, 4, negative 4, and then positive 1, 2, 3, 4. All right. So when we reduce this, this is a 1. When we reduce this one, this is a negative 1. So they are opposite reciprocal. Yes. So these two lines are perpendicular. All right. Next one. Left to right. I'm going to start with this one here and count to this. So I count 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay. Left to right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Right? 1, 2, 3. Yeah. All right, well, we've got to reduce. This one turns out to be 2/3. This one, the green one, turns out to be a negative 3/2. Is that right? Yeah. All right. So these two lines are perpendicular because they are both opposite and reciprocal. We have 2/3, and that's a positive number, and we have a negative 3/2, which is opposite reciprocal. So yes, these are perpendicular lines. All right, last one. Write an equation of a line perpendicular to this that contains point 15, -4. So the first thing we need to do is make sure that we write the line in slope-intercept form. So this needs to be in slope-intercept form. 5y minus x equals 10. So then I have to add x to both sides. 5y equals x plus 10. And now I have to divide by 5, divide by 5. Y equals 1/5 x plus 2. Now, what is the slope that I need for this line? The slope that I need for a perpendicular, for this line, is 1/5. The slope I need for perpendicular is going to be, since this is a positive number, it's going to have to be a negative number, then it's going to be 5/1. That's the slope I'm going to put into the slope, point slope formula. Remember, the point slope formula is y minus y1 equals m times x minus x1. All right, so I see my x1 is up here, my y1 is up here. All right, so y minus y1 is -4 equals slope. Well, what's the slope? The slope is down here. -5/1 times x minus x1, which is 15. Okay. When we simplify this out and do the distributing, we end up with y plus 4 equals -5x. And this turns out to be 75 plus 75. So now y, nope. I'm going to subtract 4 from both sides. We'll get y equals -5x plus 71. There's your answer. Make sure that you bring your questions tomorrow, and we'll see you then. Have a great night.